So in this video, we're going to review some 3D geometry that you've learned in the past. And we're going to be looking specifically at surface area and volume of prisms, rectangular and triangular, and of cylinders. So when you're thinking about surface area, think about things like, have you ever wrapped a birthday present? When you wrap a birthday present, you're covering the surface area of that shape with wrapping paper. And then think, what about pouring a glass of milk? If you're pouring a glass of milk, you're filling the cup up with liquid, and that's volume. And so when you're thinking of those things, that's what you want to keep in mind. If you're covering something, you're painting the surface, you're covering the surface, that's surface area. If you're filling something, then that's volume. So let's start by looking at surface area of rectangular prisms. So down here is a picture of a rectangular prism. And with rectangular prisms, you always have to remember that the top and the bottom of the prism are going to be the same. So really, you could just find the area of the top and times it by 2, and that would be the area of those surfaces. Then the left and the right are always the same. So again, you could find the area of the left side and times it by 2. And finally, the front of the shape and the back of the shape are the same. So surface area of a rectangular prism is essentially just finding the area of each side and adding them together. And there are 6 sides in a rectangular prism. So if we look at this particular picture here, it takes us through, so this is a cube, but then it actually will take us through a little bit of an interactive. So here is a rectangular prism. If we play that, we can actually see all of the pieces, and we can see them being folded up. And one of the trickiest parts of finding surface area is visualizing it. And so here you can see the net in a 2-dimensional form, and then it gets folded back up into the 3-dimensional form. So when you are finding surface area of a prism, you're going to find the area of the front. Whoops. The area of the front and back. You're going to find the area of the left and right. And you're going to find the area of the top and bottom. And then all you're going to do is you're going to add those together, and that's going to equal the surface area. And remember, finding the area of a rectangle is just base times height. So all you have to do in your mind is break the shape down into its 3 different rectangles, find the area, times it by 2, add the next one, and add the next one. So triangular prism, again, you want to think in terms of what it might look like. And a very common shape that people think of with a triangular prism is a shape like a Toblerone bar. Another common shape is one like a block of cheese. It will look more like that. So that's kind of the block of cheese type shape. Again, when you think about a triangular prism, think about the shapes that you might see. Well, there are 2 triangles, a triangle on the front and a triangle on the back. And then there are 3 rectangles that make up the triangular prism. Depending on the type of triangle that you have, there might be 1 rectangle that's the same as another. So 2 rectangles might be the same and 1 might be different. Or all 3 rectangles might be the same if it's an equilateral triangle. So if you had an equilateral triangle and all 3 are the same, then each of these 3 rectangles are going to be the same. And then if you had an isosceles triangle, so you might have something that looks more like this, then this rectangle here and the one that's in here, they're going to be the same. So this rectangle and this rectangle will be the same. And then the bottom one's going to be different. So it just depends. If it's a scalene triangle, then you're going to have all 3 rectangles being different. So let's look at what that might be if we broke it apart. So again, here is a triangular prism. And here's the video showing it breaking it down into its pieces. So you see 3 rectangles. In this case, they're all the same because this happens to be an equilateral triangle, but they're not always going to be the same. So how would we find the surface area of it then? Well, the net looks like a triangle, and 3 rectangles. So if we drew that, we have a rectangle, a rectangle, a rectangle, a triangle, a triangle. As I said, sometimes these rectangles are the same, sometimes 2 of them, sometimes these 2 are the same, and the one in the middle is different, and sometimes all 3 of them are different. So how would we find the surface area? Well, to get the surface area, you're just going to find the area of the one triangle and times it by 2, plus the area of rectangle 1, plus the area of rectangle 2, plus the area of rectangle 3. Again, you're finding the area of each surface and adding them together. And in total, there are 5 surfaces, but the 2 triangles are going to be the same. What about a cylinder? Well, let's actually look at the interactive picture of the cylinder right away, because it's kind of a cool one. So when we look at a cylinder, this is actually what the net of a cylinder looks like. It's 2 circles and a rectangle. And if we actually look at that, it's kind of cool. When that rectangle gets unraveled, what is that distance representing? Well, let's look at it carefully. What is the distance around a circle called? When we unravel it, that is called the circumference. So the rectangle in the net of a cylinder is actually the circumference. So the net of a cylinder, again, will be a rectangle, a circle, and a circle. How do we find the surface area? Well, the area of the circle is pi times r squared. And the area of the rectangle, based on what we just saw, this is actually the circumference. And this is the height. So the area of that part is actually the circumference, which, if you recall, is pi times diameter and times the height. And then we have another circle here. Area equals pi times r squared. So the formula for for surface area of a cylinder is going to be 2 pi r squareds plus your pi times diameter times height.